Hello, everyone, and I am super excited for this session. First of all, thanks a lot for joining on a Saturday, and really appreciate it. And also a huge shout out to Prithvi and Sayan for joining. So we are conducting a lot of sessions for the CNCF student community because we believe open source is for everyone. And even though you hear about these most complex projects, Prithvi and Sayan will be sharing with you how you as a student can get involved. But before we get started, Prithvi and Sayan, maybe would you like to tell the viewers a little bit more about yourself? Maybe we can start by Prithvi.
Absolutely. Thanks a lot, Kunal, for inviting us, and thanks a lot, Sayan, for joining in with me. And thank you, everyone who has joined in to the stream. I hope you're having a good Saturday. I mean, a Saturday, of course, tough day, a tough weekend. And I mean, after a tough week, you're out here, and glad to have you all here. And this is Prithvi here. A few folks might have seen me already in a few streams here and there, meetups, cloud native events, but I work as a community manager at Chaos Native for the LitmusChaos project. It's a CNCF project, and then I also work organizing a few events in the community, doing a lot of stuff. So happy to be here and looking forward to the talk. So thank you, guys.
Thanks, Prithvi. Sayan, would you like to go next?
Yeah, sure. So, hi everyone, I'm Shine, and thanks for joining in a Saturday evening. And I'm super excited to talk about open source since I myself was, it was very daunting for me starting the open source journey. And it was really amazing when I got my PRs merged into the big organization. So it was a eureka moment for me. But yeah, I'm really glad to share all the insights of how you can contribute to a project that is open source. And also, to talk about myself, I'm a software engineer at Chaos Native, and I work on this open source project called Litmus, which we'll be talking more about. So yeah, that's me. I hope you enjoy.
Thanks for sharing. And like we mentioned it, again and again, it's like these are very complex projects, but we still see so many students who are taking part as contributors, be that Kubernetes and Litmus or all these other projects. So one thing I want to share is make sure you check out the link in the description. So that's the official CNCS student community group. We are holding a lot of amazing sessions, and we hold on like chaos engineering and serverless and about Kubernetes non-code contributions. It's like we are holding sessions every week, multiple sessions every week. So only thing we require is just ask questions, ask a lot of questions if you feel stuck anywhere. And I believe we'll also be sharing how people can get involved with the community. So yeah, without further ado, let's get started. And if you have any questions, feel free to put it in the chat. This is a live session, so we'll be answering your questions throughout the sessions. And yeah, Prithvi, Sayan, take it away.
Absolutely. Thanks a lot, Kunal. So I'll be sharing my screen, and that's how we get started. So just give me a sec. Not sure if I'm sharing the right screen. Okay, I'm sharing the right screen. Is my screen visible?
Yep.
All right. So here we go. As the banner mentions, as it says, we'll be talking about introducing cloud native chaos engineering to everyone, and then perhaps inviting you all to contribute to Litmus and the project itself, introduce the project to you. And as you all are students, I don't think we are going to talking about enterprise related stuff, or all that is not going to make sense to you, but we'll be talking about what exactly chaos engineering is, what's the cloud native way of doing it, and how you can contribute to Litmus. So before getting started, a little bit about ourselves, so who we are and where we are from. So my name is Prithvi Raj. As you all know, I work as a community manager for the LitmusChaos project. The journey started last year. I was just a student like you all, and I was from a tier 2, tier 3 university, KIT university, and then I joined in Maya Data and was just started as a community intern for the Litmus project, and now here we are at Chaos Native, which is a spin-off from the company, as managing the community. And then I also work as a co-organizer for Chaos Carnival. It's a global event based on chaos engineering, which happened. The inaugural edition was hosted this year, and then organize chaos engineering meetups every month, every last Saturday of the month. You all can join that as well post this stream. And then Kubernetes community days. I think there were a lot of students which came out there. Kunal was there. We all helped or co-organized that. So that is about me. And then other than that, I mean, there are a lot of things I love, but cloud native technologies is surely one of them. So I think Sayan can go ahead introducing himself.
Yeah, sure. That's great, Prithvi. I mean, I'm like I said, I'm a software engineer at Chaos Native, and like I've been working for over a year on this LitmusChaos project, and I've seen all the ups and downs and how the platform, the project grew. So it's been a great journey overall, and I still remember opening creating my first issue to opening my first PR and everything, which is really great when you think about open source that way. So yeah, I hope you guys also have the same experience. Also, you have the same sort of experience when you jump into open source. So yeah, we'll be talking more about it. So that's about me. And feel free to connect on Twitter or LinkedIn if you like the sessions.
Awesome, awesome. Feel free to connect with us on Twitter and LinkedIn. These are our handles, and
Yeah.
we would love to answer
The
any questions and stay connected.
the links are also in the description. The speaker handles. Yeah.
Thanks for that. So getting started, what do we have in agenda? As I mentioned, we'll be talking about chaos engineering, introduce chaos engineering from scratch to you. Why do we need this? What are the problems? Talk about resiliency, reliability, and then move on to cloud native part of it. What are the different tools out there which you can contribute to? Obviously, being open source, we don't want to market a tool. So we want you to contribute to the space itself, the chaos engineering space. So there are a lot of tools which you can check out, and then what is Litmus and where you can contribute to, and then just a little bit of basics. We'll try to cover the basics of it and then invite contributions, of course. So downtimes, I'll just start with how chaos engineering came into play, or what exactly chaos engineering is when it comes to the overall real world scenario. So I'll give a very basic example. I'll give a couple of examples. Example number one: in India, we usually have great. I mean, sales. There's a big billion day sale happening every year during the Diwali period, or there's a Great Indian Festivals sale, which is organized by Amazon, which happens every year. And during that sale, the prices of each item are reduced drastically, which invites a lot of buyers, and which creates a spike in the number of users that is there. So when there's a spike in the number of users, or there are so many users that are out there, there's a possible of an outage. There's possible that the systems go down, Amazon goes down, and it leads to a loss of almost billions and millions of dollars. As you can see, there are some examples out here. In Apple Store, outage caused a loss of 25 million bucks to them, and then it was $150 million Delta Airlines lost. And I'm sure that a lot of airlines, there's British Airways, US Airlines, they have already started seeing chaos engineering as an important aspect, or chaos engineering as something which is very important, because these outages that happen, or these downtimes where the system goes down, it requires repair, the operations go down, it costs a lot to them. Downtimes just doesn't cost money, but it also costs them reputation. Well, for example, I would you know let's go back to a few months. There was one of these days where WhatsApp, Instagram, Facebook, all the technologies owned up by Facebook went down, and we were going all out crazy, because that's how social media savvy we are, or that's how dependent we are on these applications, and that's how much these applications are dependent on us for their revenue, and they went down. So that is where came the necessity of catering to resilience. That is where normal streamlined testing wasn't essential, or wasn't just what helped them move to a reliable or resilient architecture. That is why they had to test what the real world scenarios look like, or how will their systems react when there's a spike in the number of users, how will their system scale, or when there's some sort of an outage, what sort of a reaction the system will give back to that sort of a chaotic situation. So what is resilience? Let's just understand what is resilience in terms of the cloud native space, or as we are talking about cloud native technologies here, Kubernetes here. So what is resilience? So I mean, resilience is nothing but the system's ability to stay afloat in spite of vulnerabilities, in spite of any sort of an outage that is going to hit that system. But that is where chaos engineering, the term chaos testing comes into play. That what if these resilience metrics or resiliency of a system is compromised, what will happen, what exactly happens. So some examples of weaknesses or how systems react to certain outages in a Kubernetes space are out here. So as you can see, let's say if a pod, if there's a normal pod which is evicted from a node, so pod is rescheduled and the dependent service is healthy. That is an example of a resilience. But if the pod slows down and the dependent service slows down and turns unhealthy, what? Then what? That is a weakness. And similarly, when a node goes to a not ready state or a memory, there's a memory leak in a container. Everything is shifting to the containerized world. Containerization is the future, as you all know. So that is where these three are the examples of what sort of an attack can happen in a system. A pod can be evicted, there can be memory leak, there can be disk leak, there can be so many outages or faults that can happen in a system. And these are the examples of resiliency. When does a system stay afloat? When the dependent service is healthy eventually. As soon as it turns unhealthy, that's the example of a weakness or an outage. So as you can see, what CNCF says, or as we are gathering here for a CNCF students meet, there are a lot of container challenges that are out there. Reliability is a budding challenge in containers, and not just reliability. If you talk about so many challenges where chaos engineering can cater to, there's complexity, there's security, there's reliability, there's logging, and then there are cultural changes because you know a lot of students might not even have heard what chaos engineering is, let alone contribute to it. So many of you out there don't know what is this technology, where can I contribute, how can I contribute to this, what use does this have to me. I mean, obviously that's the first question that comes into your mind, right? So that is where you need to understand that when this is a survey put out by CNCF, and this survey was out there in the KubeCon Europe itself, where they talked about these challenges that are out there, and these challenges are what chaos engineering caters to, and reliability is one of them. Reliability and security are strongly one of them, which needs to be catered to with chaos engineering. So let's move on and understand what chaos engineering is. Chaos engineering is nothing but testing a system by putting in an outage that is possible in the future in a controllable way, and identify the weakness and vulnerabilities in a system. That is chaos engineering. And usually it is a production level idea. If you are aware of software engineering practices, that you move into system moves from development to pre-staging to staging, and there's CI/CD development, and then eventually there's the system moves into production. What is visible to our eyes, what we are using Amazon, Netflix, Hotstar, I mean Disney Plus, Hotstar, all these things which is visible to our eye is their systems in production. But it takes a immense amount of testing behind the scenes to understand what sort of an outage is possible to the users. When can a system goes down, when can there be a disruption. So chaos testing is deliberately putting in a fault in the system in a controlled way to understand what are the unexpected disruptions and find a cure for them. That's what chaos testing is all about. And chaos testing is done in 4 simple steps. As you can see, you understand the steady state, you understand, you basically check out the hype, I mean what exactly the system is like when it's in steady state, or how does the system behave when it's in a normal state. Basically, steady state is nothing but a normal state without requiring scalability, agility, or any sort of change, disruption in the system. And then you hypothesize the behavior of the system in a steady state, and you hypothesize the behavior of a steady system in a non-steady state, or basically in a chaotic state. So this is the hypothesis that you build up, and then you start experimenting. You start putting out the experiments, what is required, what sort of an experiment changes the system or brings any amount of change in the system, and that is where your system starts adopting to it. So I'll point you out to a page called Principles of Chaos Engineering. Okay, so this is the page which gives you the basic idea of chaos engineering. Nothing complicated. It's a very, very basic page. Talks about chaos engineering, that it's a discipline. How does it function in large scale and distributed software? How is it practiced? You start start by defining a steady state, hypothesize, and then introduce variables, basically test. And it talks about the principles. It's a very basic definition. So I'll post this in chat. Perhaps Kunal can put it out for you all.
Can you
Just a
maybe
second.
also give? We have a question here. Can you give an example of the steps?
There are a few questions. Example of a step. Yeah, yeah. I'll give it out to you all. Okay, I'm a bit distorted right now. But yeah, I'll give you an example of the steps. So as you can see, I mean, how to build resilience. These are the steps, and this is the example. Okay, so I'll put it out for you. I mean, we can have a demo later on, but you identify the steady state conditions, as in your system is like this, or your system is basically normal at this state, and then you introduce a fault. For example, a pod delete experiment. You just deleted a pod in a cloud native space, and what happened was, once you deleted that pod, that was a fault, right? A pod deletion in a space is a fault, right? So now you want to know how does the system react to one pod getting deleted. So are the steady state conditions regained? Is, once a pod is deleted, have you been able to regain that condition through which you started? If yes, then your system is resilient. It's resilient to that sort of a fault. It's resilient to a pod getting deleted, and your system won't break down if there's a fault in the system. So chaos engineering is nothing but breaking things on purpose to understand the vulnerabilities and not let them break in production, not let them break when eventually the users are using it. So if it's resilient, you go on and you inject a new fault. Now, let's say the pod delete works for it. Now you delete a node, or you induce a pod CPU hog, where you basically induce a fault which is related to the CPU. There's a memory hog, there's a CPU hog. So these are the various experiments that are out there, where you inject a fault and you understand that how will the system react to various kinds of faults that it is vulnerable to, right? And if there's a weakness found, like the steady state conditions are not regained and there's a weakness and your system goes down or it's not functioning properly, then you fix that. You fix the overall stance, whatever is happening there, and then you introduce the fault again, or you introduce a new fault according to your system requirements. So this is the workflow of how chaos engineering or a chaos test basically functions. And perhaps when Sayan moves on to taking you through it, you can see it live. But this is how chaos tests are practiced in real world scenarios. So I think Sayan can start taking it forward, and I'll be posting the links in chat meanwhile. And Sayan can explain what's the feedback loop and how basically in the DevOps space chaos engineering comes into play, because I think DevOps is something which a lot of people might be aware of already. I hope that. And chaos engineering and DevOps and SRE space runs hand in hand together. So I think Sayan can take it up and start sharing his screen.
Sure. Thanks, Prithvi. Let me share my screen. Give me 1 minute. Okay. All right. Awesome. Cool. So we already saw the flow of how it's actually done through that step-by-step process. And I want to talk more about how you can do this in your particular DevOps loop, right? So typically, what we have experienced till this point of time is mostly tests are done on the left side of the DevOps loop. What I mean by that is, if you see the left side, it's all about building, testing, coding, and planning, right? So mostly people do smoke test or load test, or let's say E2E test, integration test, unit tests, and all those kind of tests are mostly done when you are either developing or you put it in the CI. But what happens when you shift to more of the deployment part, when you are monitoring your application, when you're in the ops side, basically when you're pushing it in a CD environment, then we do not really test it, because we already have tested it in the dev side and we are pretty confident that it won't break. But let's say, like Prithvi mentioned, let's say you have a network loss, then what happens then? You did not test that in a unit test or E2E test, so that's when your application is in danger. So that's why we believe in this concept that with chaos engineering, you should focus your tests more on the ops side too, along with your dev side. So that does not mean you neglect the dev side. You move your testing to the ops as well. So That was the original idea when we started off with chaos engineering. But as more and more use cases grow, we have also shifted the chaos test to the dev side. What I mean by that is you should be able to inject chaos in CI, or let's say you have a pre-production cluster, or let's say a development cluster, a development environment, a dev environment, let's say, where you run your applications. Then you should be able to do chaos testing there as well. So you should not have any sort of uh, you know um, um, like a blocker in that area. So you should be smoothly able to do chaos engineering both on dev as well as ops. So that's the idea with Litmus. And the general idea with chaos engineering is you should focus more on the ops too and not neglect the dev. So you have a pretty safe service. Now, moving forward, how it is typically done. Now, these are a lot of fancy words which I'll be explaining in, like, breaking them down, explaining in very simple ways. So, what are game days? You see this word connected with chaos engineering. Whenever if you Google chaos engineering, you are bound to find game days at one of the examples, or like one of the links. What are basically game days? They're like typical fire drills that we do with chaos engineering. So what happens is an entire team or your entire company or some set of particularly people, SREs, would gather, and they would purposefully inject chaos on your system, on your application, to check if everything is working fine. So they would intentionally induce chaos and see the resilience of the entire system, and that is completely monitored and manually executed. So if there's any sort of fault, then you would know beforehand that what exactly broke and why, what I need to fix. It's better than better safe than sorry. So and also, like, in the second point, you see really integrated into CI/CD, which I just mentioned. A lot of approaches haven't been doing this, but we definitely need to shift more on the CI/CD part too, so that developers also get advantage of chaos engineering, and it's not just the ops team. Also, only for SREs, this I also mentioned, it was mostly made for the SREs, but developers also have the chance now to engage in the chaos engineering process. And also manual execution and planning, what it basically means is, for every chaos injection, there has to be some sort of plan, right? Because let's say you're running an application which is, let's say, an e-commerce application which is selling something. For that particular application, you might have a nav bar, you might have some catalogs, you might have a database connected. So it's your system. I might not use that same database. You might use Mongo, I might use Redis. That's my every individual's choice. So everything that you do in your application has to be specific to your needs, and I cannot know that. So therefore, everything that was done previously was manual, and everything had to be broken down into multiple parts. Let's say it's very redundant. You write tests for Mongo, you write tests for your framework, your toolkit, whatever you're using. So with the idea of Litmus, we try to make it much smoother and automate the entire process. It will only ask you what kind of application you're running, what kind of test you want to run, and it should create a test for you, a test suite containing multiple tests, which are wrapped up in one singular workflow. So that's what we call as a workflow, which is like a multiple layers of individual chaos tests. So I can try deleting a database. I can try cutting my network off. So there are two tests making up one single workflow. So you just run the workflow and everything executes. So that's the idea. And also chaos observability. So if people are not well versed with the idea of observability, what it means is you want live monitoring of your system. You want the data to be there integrated in your particular setup, in your particular service, so that when you do something, you get live metrics of the same. So you might have your own set of tools, right, to do it. You might not like one tool, you might go for any other tool. So in the typical flow, these tools were not very smooth in terms of integration, and a lot of custom build stack were very difficult to incorporate for the enterprise as well as for every general user. And also the same point connects to custom measurement process. So there was no custom measurement process because there was no set path for custom build stack of your observability. So there was these flaws as well in the typical process. So why did we choose Kubernetes? Because, as you know, Kubernetes is already the de facto standard in the industry, and Kubernetes is moving up the chasm very quickly. And Kubernetes is also like an open source container orchestration tool, which is gaining a lot of popularity and is maintained by Google as well. So, sorry, it's maintained by CNCF, not Google. So Kubernetes is like the de facto standard right now in the industry. So what the general idea was, you build your chaos engineering stack on top of Kubernetes, and then all the applications that are running otherwise, you can inject chaos in all these applications, whether they're running inside of Kubernetes, whether they're not running, you're running it in a separate cloud provider, you're running it in your separate dev cluster, you're running it locally. So all these different areas that you're running your applications in, the particular tool set that is built on top of Kubernetes would be able to inject chaos everywhere. So that's why. And chaos engineering for Kubernetes is getting more and more popular due to the idea of more availability and resiliency that comes with it. So when your application is cloud native, when your application is built on top of Kubernetes, you automatically get a lot of scalable options, ideas, and you already get so many ideas for adding more replicas, scaling your applications higher, high availability, distributed systems, and so many things comes along with this idea of getting your services up and running in Kubernetes. So why chaos engineering? Why chaos engineering specifically in cloud native and specifically in Kubernetes? So with your platform services that are running, you have Kubernetes on top of them, right, to manage all this scalability, this high availability and everything. And then we'll come to cloud native, what exactly it is and why we need it. But if you just move on to the layer that's on top of it, which is the others, you see Kafka, Mongo, and Postgres, and all these different services, right? And then on top of that, you have your application. Imagine a monolithic application. You have a monolithic application which is, everything is jam packed in that particular your application. So you have to write one single gigantic piece of chaos tests suits which would target individual things. But with the cloud native approach, you have broken things down into multiple services, and you can target each individual service based on your requirements. So you can target one particular Mongo database. Let's say you can target your maybe an ingress controller or anything. You can target your monitoring setup. You can choose which layer you want to target, and you can only write applications in detail specific to your requirements. So that's the main reason why chaos engineering is gaining so much popularity in the cloud native space in general, as well as in the cloud native. Now, since more and more people are shifting to cloud native, it's getting much more popularity in the cloud native area. Now, coming on to cloud native chaos engineering. So what is cloud native? Cloud native is basically, it's an idea, it's an approach of leveraging cloud computing to its fullest to have more scalable and high available options for your service, for your application. So with cloud native, you divide your applications into multiple microservice layers, and you get these options to scale it more. You get a modern and like you get a modern way of building things, so that way you can segregate each and individual components whenever you want. You can have a dynamic environment, you can add everything. You can add serverless, you can make it serverless, so you can do anything you want. You can also make it switch into a hybrid cloud as well with the cloud native approach. So it's very flexible and also very modern, and you can get much more dynamic content as you move forward in your cloud native journey. So let's say some requirements pop up later, you can easily integrate it into your system. So what are the main principles of cloud native chaos engineering? It's typically it started out as it should be open source. What I mean by that is it should be available, or not only for you as a private customer or something. The main principle of cloud native is it should be open source, and the concept should be out there. It should, and with that, obviously, you get community collaborations as well. What I mean by that is, let's say you have a project which is following the cloud native principles, and the community is always there to help you out. They as your projects move up in the ladder, then the community of course collaborates. Since it's open source, they are free to do feature requests, they're free to add more features, and that's like a hand-in-hand process where you grow along with the community. So the community is helping you out to grow. So that's the two things that are interlinked, and that is absolutely a very important factor for cloud native chaos engineering, the major principle. Second is open observability, and like I already told you what observability is. It should be open because you should not be scoped to one singular approach of monitoring. You should be able to integrate any service, any monitoring tools that you want, and it should work seamlessly with whatever project is in a cloud native space. Now, open APIs and lifecycle management. What I mean is, let's say your application is using certain APIs and certain processes, certain plans. Those plans, those processes, those APIs should be flexible enough that any of that you can integrate them in any of your other services. They should be written in such a way that they should be open. So the entire concept of openness comes along with cloud native chaos engineering. And the fifth point and the final point is GitOps. Now, if you are not familiar with GitOps, it's basically like DevOps, but it's built on Git as a DB. So you're using GitHub as Git as a DB, and then you can use this approach to store events and track who is doing what, and you get a very version controlled. You get a very versioning system on the application that you're running, so you can see who did what, and you can go back in the history and basically leverage all the features of GitHub. So what are the benefits of cloud native chaos engineering? You can run services without an outage, since you already have tested your cloud native microservices with a chaos injection, and you know that these are running. So I am free from the doubt that they would break in production, because I already have tested them. So you can run them without the thought of an outage. You can run these services to meet the business SLAs and SLOs. What I mean by SLA and SLO is, let's say, to sum it up, you have promised your provider that you would provide this. You provide 99% uptime. You would make sure that your database is running 24/7 or something like that. So you have made some agreements with your provider, and you need to actually maintain those agreements. You can't say that I'll be running 24/7 and then just hit a downtime and then you don't. And actually, that's disruption of your SLAs. So you need to enforce these concepts these agreements that you're actually making, and that is where chaos engineering helps you reinforce these concepts. And you can scale your services on demand, because you already have this chaos engineering wrapper across your entire service. Now you can easily scale up and down, because you already know that this won't disrupt. And if it does disrupt, then I already have my chaos workflows up in place. So before I actually scale it, I would run my chaos workflow, and I would see actually if there's any problem in my system. And with that, also the fourth point is connected, that you can upgrade your services without an outage, because of course you have this wrapper. So you would feel free to update without any outage, because you're outage free with this approach. Now, there are, of course, different tools in the market. Currently, I am working on Litmus. I am a contributor to Litmus, but there are other great projects as well in the market, which is Chaos Blade, Chaos Mesh, Chaos Toolkit. These are great projects. You can also go ahead and Google them and find their GitHub repos and contribute to them as well. But what we typically try to do with Litmus is, we found a few issues that were there in the chaos engineering market as of now, and we try to mitigate those issues and make things much simpler and better for the community overall. So a few of the major issues that were there was, some projects were pretty great, but they were scoped to certain market, let's say, and the documentations and everything were available only in one language, and people were facing problems contributing or even reading it. So that was one, that it was specifically only for a particular country or so. And then there was this other problem where everything was running great, but then you hit a security flaw, and then all your data might not be very secure, and then you would not obviously want to sign in specifically for something that is not secure. And thirdly, other tools were pretty great, had everything that's needed, but then there was no native scheduling available. What I mean by that is, for every test that you do, you have to schedule it manually, and that's, like I mentioned, the first thing that you run. If you have a gigantic application, you run everything from start to bottom, then it's a huge burden. You can do it, but it's everything you have to do manually, so it's like a lot of time is invested on that. So there comes Litmus, where we try to mitigate all these problems. But what exactly is Litmus? Litmus is a cross-cloud control plane for cloud-native chaos engineering applications. Now, let me break it down. It's a mouthful. So what is cross-cloud? Cross-cloud is basically, you can run your service, you can run this portal, this control plane, on AWS, let's say, for example. I'm not specifying it. You can run it on GKE, AKS as well. You're running Litmus on AWS, let's say, and you have your application. Let's say this e-commerce application you're talking about, it. You have this e-commerce on GKE. So running Litmus from AWS, you can do chaos on GKE. Or if it was on Azure, you can do it on Azure. Or if it was on Rancher, you can do it on Rancher. And actually in the repo, you get a list of all these different platform supports that are there. So Litmus is supported on all these different platforms, and you can have Litmus running in any of them, and you can inject chaos in any cluster running anywhere. So that's the benefit. It's cross-cloud. So you can do anything from anywhere. That's a advantage. And secondly, since it's cloud native, you can always target cloud native services that are running. And so you can target your particular microservice, which is, let's say, a Mongo pod, or let's say a particular, you can also target VMs, you can also target containers running EC2 instances and everything. So there's a lot of flexibility that comes with this tool. And also it was started out as a tool for SREs, which is now pretty flexible for both developers, DevOps. You can do CI/CD and all these things that I just mentioned. Now with Litmus, we tried to follow all the different principles of cloud native chaos engineering, and we are very happy to say we have successfully done so. So all these different principles that I talked about, we are actually able to, we have managed to actually incorporate all these things. So our APIs are open, it is of course open source, and we are doing a lot of community collaboration. So as students, you can also get involved and do a lot of community collaboration. So it's not just limited to enterprises, it's like flexible for everyone. And also observability is open, and of course it has GitOps too. So I'll let Prithvi talk about contribution, but before that, I just want to show you something. Like someone had a doubt about this entire process, which Prithvi mentioned about resilience and how it's actually doing it. So what I have here is I actually have Litmus running, and I'll just give you a very brief overview of how it looks, how the web UI looks, how your chaos experiments look, and how you can basically get started, what are the different repos that are there which you can leverage and use to contribute. So let me just get started here. What I have here is just a Litmus installed. This is a Minikube container, by the way. So if you have, let's say, if this is not production, this is not AWS GKE, it's just Minikube. So if you have K3s, you have Kind or any of the dev cluster, you can easily get up and running. So that's the good thing about it. Like when we do development, we always use these kind of dev clusters. So it does not have
zoom in a little bit.
Yeah, sure. Is this good?
Yeah, looks good.
I think this should be visible. And let me just also increase the size here. Okay, so this is the dev cluster that I'm running. And it's not scoped just to production. So you do not have to have a AWS or like a cloud account in order to run Litmus. You can do it everywhere, anywhere. You can run it on your dev cluster too. So if you have K3s, Minikube, and all those things downloaded, you can of course download them from their official documentation, and you can get up and running with Litmus. So I just have it installed, and to know the installation process, if you just come into this repository, which also Prithvi will share the link as well. So if you come into this repository and go to this Litmus portal folder and just scroll down, this in the README section, you get all this different list of options of how to install. You have the manifest and the master scope manifest, the namespace scope manifest, and those things. So you can easily read these and get to know how to install. It's pretty straightforward and simple. Also, there's this option of Litmus docs beta, which is another documentation which you can also use to get to know about the installation steps. So in the getting started installation control plane, there's two options: cluster mode, namespace mode. You can of course learn a lot about these two. So you have the installation steps right here, and it's just pretty straightforward. You just apply one single command and it's installed. But anyways, I'm not going to talk about the installation. So post installation, this is how it will look. So you would have one agent connected. An agent is nothing but this Minikube, or let's say if it was AWS, it would be AWS. If it was GK, it would be GK. So whatever is connected in, that is the self agent. And if you connect any other agent, that will be external agent. But those are like advanced concepts. So I'll just leave it to that. So this is how it would typically look. This is the UI. I have run one single workflow, which is an Nginx chaos workflow. So what I have done in that, let me just go to workflows. And this is the workflow that I ran. If I just click on this, you'd see this UI where you see the different steps. So what I did was, this is my main initiator. I installed the experiment, which was a pod delete. I deleted a pod, which is my Nginx pod. So I had an Nginx pod running obviously the Nginx service. What I wanted to do was I want to inject a chaos and delete that particular pod and see if my system, which in this case Kubernetes and Nginx, is resilient enough to take it back up. So by default, Kubernetes would, because Kubernetes is pretty resilient and it doesn't allow any, like if a pod terminates, Kubernetes will automatically try to create another, since it's a deployment. So I intentionally tried to inject a pod delete fault on Nginx. So what that did was it terminated my Nginx pod, and Kubernetes actually respawned that pod. So that's why, since it respawned and it did not break my application, that's why it's resilient. If it had broken it, you would have seen an error mark with a cross and saying that something went wrong, and you can check the chaos result or what went wrong, and then you can go back and try to fix it, right? That's just what Prithvi mentioned at the beginning. So you hit a fault, you go back, try to fix it, and do this experiment again. So this is how it would typically look. And if I just scroll down to the result, I can see the phase is completed, verdict is passed, my experiment passed. And also my resilience score in this case is 100%. So it's pretty resilient, the most resilience that it can get. So yeah, that's how a flow in the portal would typically look like. You have all these other settings of adding teammates and stuff in your project. So you can have multiple teammates, you can create multiple users, you can have the GitOps enabled, you can create, if you have your own image, you can actually put your own image in this in your workflows. And also when you create a workflow, it's not just scoped to like the hub, right, that was there, which is, let me just open this. These are the list of experiments that we provide you by default, but it's not like you have to use them. These are just like templates. So if you do not want to, you can of course select this and create your own experiments. These are all like different steps of how you can do it. Now jumping off to our publications and where you can contribute. So if you go forward and learn about, explore more about Litmus, you can of course have these like the dev2 publication that we have, dev2/LitmusChaos, where you can write blogs about it. We have the same for Medium, where you can write blogs about it. And also there's these repos, which are like the Litmus bot, github.com/litmusbot, which the username is actually Litmus Tutor, where you have these scenarios. So let's say you do a pod like the one I just did, Nginx pod delete. I do not have a scenario for that. So what you can do is you can go to this Katacoda scenario. We use Katacoda for scenarios, by the way. So you can write your own scenarios and contribute that. And scenario writing is very easy. It's not like you do not need any code level knowledge. If I go to container kill, it's all like MD files, as you can see. It's one JSON and MD file. That's what Katacoda requires. So you can, of course, take a look at the scenarios already present and contribute more. You can, of course, go through your own flow and create that as a scenario and contribute to us. And if I just come back to the main organization, which is LitmusChaos, there are of course the portal, the main repo, which is Litmus. You can of course contribute there. But two other important repos which I would like to mention are website LitmusChaos. So if I just go to website LitmusChaos, this is the litmuschaos.io website that we have, which is this one. Yeah. So this one, and if you figure out any bugs or flaw in this website, you can of course feel free to contribute. It's written entirely in Gatsby and TypeScript. So if you know any of those, then you can of course definitely contribute. If you do not, you can contribute to the documentation. You can contribute to maybe the optimizations, the different packages that we use. Maybe you can optimize them. You can create your own solution for optimization. So anything possible. So this is one website, LitmusChaos, and I'll be sharing all these links, obviously. Also, there's another thing which is called test tools. So if you are more into testing, if you are more of a tester, then you can of course visit this repo and you can create tests in Ansible, Python, Go, and you can see a lot of like tests written here. And these are not chaos tests. These are like tests we use to make our own resilient system more resilient. So things like Ansible tests, things like IO tests, things like load tests and those things. So we do all this kind of testing here. So you can of course contribute to these repos if you are into testing. So that's it. I am going to hand it over to Prithvi and he can talk more.
Thank you, Sayan. I was actually busy answering questions, but I'll take it forward on how folks can contribute, what exactly. I mean, this is mostly for the students community, so I think focusing on them was the priority. So let me just take you through a little bit on the contribution side and what exactly you can do. So firstly, I would like to, yes, Kunal?
Yeah, I just want to share something. People are asking, so yeah, we'll be doing a swag giveaway as well. So I have a few coupons from the CNCF, so you can go to the CNCF store and get anything you want. There might be some chaos engineering swags there. I'm not sure. So are there LitmusChaos on the CNCF store?
I am not.
No.
No. LitmusChaos facts are not there, but I think
Another
Kunal
chaos
has.
engineering.
Kunal has put out a swag giveaway, so I'm sure that if we find out the best tweets on Chaos Engineering or
Yeah.
Litmus on Twitter, then I'm going to give them swags from the Litmus Chaos end for sure.
So now you can see you're getting swag from two sides, one from CNCF store and one from the Litmus Chaos. So basically, people are asking how to take part. So basically, you can share about what you learned in two ways. One is you can write a blog about this session, so you can write the entire summary of what you learned and what was presented. It can either consist of what you learned or the technical and hands-on demos that Sayan presented, or you can also put it in a Twitter thread. So you can have like a few Twitter threads that mention what you learned. Both of these you can share on Twitter. So if you have a blog, you can share the link on Twitter, and if you have threads, you can share that on Twitter as well. Make sure you tag CNCS Students Group and Litmus Chaos, and by tomorrow or day after tomorrow, we'll reach out with the winners. Prithvi, take it away.
Sure. So talking about contributions, I'll talk about. Just give me a sec. Okay. Yeah, I hope my screen is visible to you all. Is it? Yeah. So getting started with contributions. How do you get started, and what exactly you can contribute to? So now students are pretty. They ask us that how can I contribute. So see, there are good first issues, although there are not a lot of good first issues labeled out there, but there are certainly a lot of issues with the development of the portal. And for your information, Litmus 2.0 is releasing on the 15th of August. So it's already in advanced beta, but the GA comes out on the 15th of August. So I think with that, it changes the chaos engineering scenario completely. And with the evolution, there's a UI. There's as you saw the portal, I think it's comes out with all the functionalities and the updated docs. The beta docs link, I think Kunal has already posted. So there are a few good first issues that are already out there. And if I think the best way to contribute to any project, not just Litmus, is to join their Slack community and interact with their maintainers, the contributors. That is where you understand the project in a very detailed way and you understand where you can contribute exactly. And I saw one of the episodes recently on non-coding contributions. So in case you're not able to contribute to the code, I mean, there are, as you can see, you can contribute. The experiments are written in Go, so you can, if you have some knowledge on Go, Helm, GitHub Actions, Kubernetes, then R, Ansible, then obviously it gets easier to contribute experiments or at a deeper level in the backend. But in the front end as well, you can identify issues in the portal itself. Right now is the best time when it's the GA is not out, so you can identify issues in the front end, in the website, in the portal, or you can contribute. Non-coding contributions can also come in terms of documentation and the developer docs. So the docs, the beta docs are already out there. I think it's more important to understand what chaos engineering is. So before getting started with Litmus, I think before getting started with contributions, what is important is to understand this technology more. I don't think one single talk or a few podcasts or talks will be enough to understand this scenario completely. But there is ample amount of resources which are out there in the community, and you can check out the tutorial videos. So I think I'll share the link to that as well before answering a few questions. So you can check out tutorial videos which are out there, and they will help you understand what Litmus is more and how you can contribute in terms of blogs, in terms of documentation, in terms of podcasts, in terms of, community outreach programs. So there's a lot, and you can always reach out to me so that whenever you want to contribute or you have something in mind, we can get you in touch with the maintainers and try and bring out the best contributions for you and list down a few good first issues that are out there. So next up, as you can see, these are the main aspects where you can contribute to. The code is out there on GitHub, and then there are the docs. The 1.x docs are already live, and the 2.0 beta docs are already in development, and there are a lot of people who are contributing. I think one of them, I want to give a shout out to Divya out here. She's an amazing member of the community. And then join our Slack, see what other folks are doing. There are a lot of college students who are researching on chaos engineering, who are understanding what chaos is, contributing in some form or the other by understanding the resources. Take a look at the resources. We have shared a few, and then post that. I think I always say that learning is what helps you contribute. So once you have some amount of information or you have some knowledge, then I think the contributing part gets easier. It becomes really easy for you to contribute to the project or to the technology itself. So I think with these are the resources again, the blogs, Slack, GitHub docs, and with this we come to the end of the presentation we have. So perhaps we can answer a few questions and then share some links and then
Yep.
end it. Yeah. So
Awesome.
I just
Thanks a lot for the presentation, Prithvi and Sayan. I've added all the links in the description. So like links to, tutorials and resources and some helpful links and even like everything. You can see I added a bunch of links, like dozens of links. So yeah, before we get started with the questions, make sure you follow, LitmusChaos on Twitter. Follow CNCF Students Group on Twitter. We'll be announcing winners over there and also sharing some nice resources. But let's see if we have any questions here. We do see quite a lot. So we have a question from Abhishek. What are the other chaos tests that we can do?
Other chaos tests you can do if you go to this hub.litmuschaos.io, right? This is the um, like a repository of all the chaos tests that we are providing right now. Oh, hi. So yeah, if you go to this list of repositories that are there with all the chaos experiments, you can hit node level chaos, you can hit pod level chaos, you can do container level chaos, you can also do application level chaos. What I mean by that is, let's say you have Kafka, you have Cassandra, you can also kill your Kafka or Cassandra applications with that. And also if you have your own application, like I said, a monolith application, you can also hit that monolith application, but we do not have that right now. So you have to create your custom chaos. So if you want to create a chaos which drops stable in, let's say, SQL or Postgres, then you can of course create that using your custom options, and then that should be doable.
Thanks for sharing. There's another question. I believe there are. So I believe LitmusChaos or Chaos Mesh project both take part. You can check out in CNCF/mentoring repository. But would you all like to share something?
I think Prithvi can share this.
Yeah, of course. I mean, in the mentorship program itself, you have Litmus and Chaos Mesh, and then Blade is also coming up. So there are already mentees who are part of the LFX mentorship and then the GSOC program. And I think for the next summer itself, I mean, we are planning to put forward more use cases or problem statements that are out there which you can solve and grab an internship to. And then I think I mentioned this in chat as well. So what you can do is once you start contributing to the project, I think the maintainers of the project or the ones who are providing support for the project, I think they are the ones who provide you with some sort of internship opportunities, and you can get access to more opportunities that are out there. And I think this happens with a lot of projects out there. Every project has some form of internship opportunity available through their maintainers. So I think once you start contributing, as I said, join the Slack channel, start interacting with the community leads and maintainers, and then I think this becomes an opportunity for you. Yes, Alka, steady state means system without any faults at any present, or basically how the system is in normal state.
I'd like to add a bit to that. Steady state, it can be a system with faults too, if let's say it's what you imagine your steady state to be. If your steady state is something not working and your hypothesis is you breaking it more to make it not work more, I don't know why you do that, but if you're willing to, then something that is not working at the initial part, that was your steady state. So you would define your own steady state, how you see your application as steady, when you see your application as steady.
Thanks. There's one more question on the screen.
Yeah.
Indeed, I think the pod delete experiments occurs in production. I mean, not just pod deletion. There are so many faults. I think Kunal just posted the link to all the experiments that are out there, and there are a lot of chaos tests that one seeks. I mean, it can be a fault in your Kafka workloads, MongoDB workloads. It can be a container kill. It can be a pod network loss, or basically it's understanding what can happen to your workloads when your system is in production. So when you understand that, then you are easily able to identify the experiment that is required for you to test that system, and then come up with it. Then you come up with that chaos test. So that is the process of it. And it's just not a pod delete experiment. We just took a simple example for you all to understand. But if you check out the chaos hub, it's a marketplace. No other project provides you with such sort of a marketplace. So I think you get to understand what are the possible tests. And then there's stress chaos, IO chaos. All that will be coming up very soon. I think most of it is there as well. But also, one more idea of it is Litmus provides you with an SDK, so you can write your own experiment and run it with Litmus. So all of it
Yeah.
becomes pretty easy for you.
Yeah. And like
Okay.
Prithvi mentioned, one session is not enough, in order to be pro or even like a contributor. This is enough to get you started, because all the links are in the description, and we gave a really nice introduction. And also you can join the Slack community, of LitmusChaos. All the links are in the description. Just get involved, ask questions, learn, experiment, go through the resources, and contribute. You have one more question on the screen.
So yeah, Litmus does support RBAC. Litmus is built on RBAC as well. Right? So when you install Litmus, it installs all the necessary RBACs that you require, and also it has a CRD called Chaos Operator. If you want to learn more, you can check out the blogs, which is actually controls all the functioning. So yeah, it does involve RBAC, and also you can do namespace scope installation of Litmus as well. So if you are in a shared cluster, you can install Litmus in the namespace, and also you can have your applications running in the namespace. So yeah, that's good.
Yeah. Also, shout out to Nilanjan. He's been answering all the questions in the chat. So really appreciate that. Cool. Just one more
I
question
think
on the
I have
screen.
one more question. Yeah, largest scale I mentioned, it's 10,000 workloads, 10,000 plus workloads that we have run Litmus with. So I think, I mean, from our local machine, if they can be tested on more than 10,000 workloads for sure. One more question I see is talk about the future of chaos engineering from the employment perspective. I think this is something the students are really, really interested in, and I would like to talk about it a little bit, because every other day we are working in this space, and every other day what happens is we usually get to see a lot of people demanding chaos engineers. I'll give you a very simple example. TCS, I mean, mentioning them because they have gone all out about it. So every other company today requires chaos engineers, and chaos engineering as a technology is in demand because it hasn't crossed the chasm of generic market adoption yet. People are adopting it, but just because there aren't a lot of skilled people, the adoption is taking time, or people want that skill. People are actually paying tons of money for that skill. So I think from the employment perspective, in case you are able to have knowledge on chaos engineering, there has to be a lot of demand for you. I'm pretty sure about it. And then just because the need is at a high level and the availability is low, so you understand how economics works and how the supply and demand fraction follows everything. So I think if you are well versed with chaos, then from an employment point of view, you are in a good space. So I hope that answers all the questions that student had. And
Yep, just
do
one
we
last
have
question, I believe, because we answered all the questions. So this is just one.
indeed do I know it need to Sayan can take this up? I answered this, but if Sayan can elaborate a little bit more on this.
I don't think you need to. It's like if you when I started out, I just learned about microservices. So if that should be enough. Like I mean, you just have to learn about cloud native, and that should be good enough. You don't need to learn about distributed systems in a broader term. You just need to know
Cool.
about cloud native, the concepts and everything. That should be good.
Cool. Alrighty. Well, thanks a lot for joining, everyone. And once again, looking forward to reading your blog posts and what you learned. So make sure you share about it on Twitter. Tag CNCS students. Tag Litmus Chaos project, and Prithvi will also reach out for some Litmus Chaos swags. It's important to because everyone we provide roadmap to everyone, but only a few people follow. So if you're interested, it's a great opportunity. And like Prithvi mentioned, there's like a lot of nice job opportunities in this domain as well. Also for students, there are so many beginner friendly issues and internships and mentorship programs. So we'll do like maybe a separate session on the mentorship programs and stuff. But thanks a lot for joining, everyone. And Prithvi, Sayan, do you have any closing remarks?
Of course, Kunal. I think the interaction was awesome. Cyan can add more to it, but I loved the interaction and the questions. They were amazing. This session, I thoroughly, absolutely loved it, and I hope that we can have more such sessions. And I look forward to all the sessions that are happening out there in the student community and all the communities. Kunal is doing an amazing job. Kudos to him as well, and thanks a lot to all the students and everyone. I think I think not just students, a lot of folks joined in, so thanks a lot for joining in, and it was an absolute pleasure.
And I'd just like to add that do not feel daunted by the open source community. I know the
Mhm.
feeling. I was like that when I started out in my first year of college. So feel free to just get your PRs out there. If there's any problem with your PR, the maintainers would of course let you know. So do not get bogged down by it. They'll of course help you understand what's the problem and help you get better at open source. So feel free to just raise a PR.
Yeah, most definitely. All right. Well, thanks for joining, everyone, and we'll see you in the next meetup. Bye.
Thanks everyone, bye.